I hope you're able to see my screen. Yeah. So we'll start with the first problem, listen guys. So question number 1. A disc is rolling without slipping on a horizontal surface. C is its center. Q and P are 2 points equidistant from C. Let VP, VQ, and VC be the magnitude of velocities of points P, Q, and C respectively. Then which of the following is right? Okay. So a disc is rolling without slipping. So they have mentioned it. So what kind of a rolling is taking place?
Pure rolling.
Yeah, that's right. So there is pure rolling taking place. When pure rolling is taking place, what is the velocity of the center of mass?
R omega.
P is equal to R omega, where R is the radius. So if that is the case, what can you say about the different points that you have? So what can you say about the velocities of different points? Yesterday I told you, right? What is the velocity of center of mass? It is V. Now what will be the velocity of Q? It will be V vector plus, if I call this distance as R omega, it will be R1 omega vector. Similarly, what can you say about point P? It will be V vector minus R1 omega, R2 omega vector. You remember this? So out of all these three, which one is least?
P is least.
So P is least. So P being least is option A and D. So which one is right? So compared to C and Q, which is having more velocity?
Q.
So answer is A. Are you guys able to understand this?
Yes, sir.
Yeah. Okay. Shall I move on to the next one? By the way, one more information. Don't look at this problem like there's actually not a problem, it's a concept. Velocity of any point above the center of mass will be more compared to the velocity of any point below the center of mass. And velocity of center of mass will be the moderate one. Okay. So have that in your mind. Next. Let me copy this question. Now see. There is a uniform rod of length 12 which is placed with one of its end in contact with the horizontal and then inclined at an angle theta to the horizontal. Is allowed to fall without slipping. Is allowed to fall without slipping at contact point. When it becomes horizontal, its angular velocity will be. How to even solve this? Are you guys able to visualize it? Showing it to you. Wait. Yes. See, the horizontal floor is there. Okay. Let me say this book is the horizontal. So on this horizontal floor, there is a rod of length 12 that is placed. So if it is placed like this, what will happen to this rod? If I leave this, what is going to happen? What happened actually? It fell like this, right? So what happened? It rotated. So they are saying there is a uniform rod of length 12, which is making an angle alpha here, kept like this. Okay. So when this becomes horizontal, what are they asking? The angular velocity, right? What is the question?
Yes, sir. Angular velocity.
They are asking angular velocity, right? So they are asking the angular velocity of the rod. When they say angular velocity of the rod, every particle on this rod will have the same angular velocity. And one more condition that is given is this point is not slipping. Okay. Now tell me what concept can be applied here. What concept can be applied here for this thing? What comes to your mind, guys? One more thing, don't stop your thought process restricting it only to concepts of this chapter. You can think from other chapters also. So if I take the rod, okay, the rod is of length 12, right? That's what they told. Yeah, the rod is of length 12. Its center of mass will will be somewhere over here. This is mg. This is alpha, right? How much is this distance, guys? It is L, accepted because it's a uniform rod again. Uniform rod means the center of mass is exactly going to be its center, right? And the rod is revolving. Let's say it is revolving with an angular velocity omega. Now tell me one thing. What form of energy did it possess initially, getting converted to what other form of energy?
Potential energy to kinetic energy.
Yes. So it had gravitational potential energy and it is converted to
Kinetic energy.
it is rotational, only rotational part. It doesn't have any translational. It is converted to rotational kinetic energy. So gravitational potential energy is mg into height of the center of mass from the reference point. If I take this as the reference line, what is the height of the center of mass? What is the height of the center of mass, guys? Apply right
Sine alpha. L sine
uh,
alpha.
L sin alpha. Yes, it is L sin alpha. Right. So mg into L sin alpha is equal to what is the rotation kinetic energy? Half I omega square. Half into here I, what should I write? What is the moment of inertia of a uniform rod?
ml square by 12.
But my question is invalid. What should I should have asked something. Moment of inertia of a uniform rod. I didn't mention the axis of rotation. No. In this case, the object is rotating about which axis? Is it passing through? Is it? Excuse me. Is it rotating about an axis which is passing through the center of mass?
No, sir.
Isn't the axis of rotation here, is it not at one of the ends? Then what should have been the moment of inertia? M into L square divided by 3. Don't forget that. You cannot keep deriving every time. So moment of inertia of a uniform rod about its center is ml square by 12. About any one of the ends is ml square by 3. You can get it using parallel axis theorem into omega square. So mg L sin alpha, m and m are gone. Right. 6g L sin alpha divided by 4L square is equal to omega square. 3 by 2 and 1 L will get cancelled, which implies omega is equal to root of 3g sin alpha the whole divided by okay. Actually, all these problems in exam you can do it in a minute. Only thing is, since we are discussing the concept, it is taking longer. Right? Concept wise, it is easy only, right?
Yes, sir.
Yeah. Write it down. Just a minute. Shall I proceed to the next one? So according to the theorem of parallel axis, I is equal to ICM plus mx square. The graph between I and x should. You guys tell me. I is taken on y-axis. X is on x-axis itself. Y is equal to, it is in the form mx square. Can I write some constant plus 4ax square?
Yes, sir.
So what is it? What equation does it represent? Or I can just
Option
write
C.
it as, yes, it is option C. Because y is equal to x square is actually an upward parabola. Had the C not existed, then answer D would have been the answer. Since a constant is existing, there will be a shift in origin from the bottom. There will be a shift in what? The vertex of this parabola. So it has got shifted slightly up. So it's a simple question. Question number 4. A solid cylinder of mass m and radius r rolls down without slipping on an inclined plane of length L and height h. What is the speed of the center of mass when it reaches the bottom? See, actually, for this, there is a formula which I will show you now how to derive. Going forward, if you get this kind of a question in exam, you can actually use it as a formula. See, listen. There is an inclined plane. Let's say the angle of inclination is theta. On this inclined plane, there is an object rolling. It can be any object as well. Okay. Let us say it is released from a height h, and let the radius of this object be r, and the angular velocity of this object be omega. Okay. And when it is starting from the center, let its velocity be vcm. They're asking with what velocity the center of mass is going to reach the bottom. That's what they're asking. What is the speed of the center of mass when the cylinder reaches the bottom? Again, the same logic. Tell me, what form of energy is getting converted to other?
Kinetic energy to potential energy.
No, no, no. You're telling the reverse. There is no kinetic energy initially. Initially, the object is released from rest actually. Right? So initially it is released from rest. So it has potential energy. mgh is converted to what other form?
Rotation
Half.
and translational
Yes,
kinetic energy.
yes, that's right. It has half mv square plus half I omega square. Right? So mgh will be equal to half mv square plus half into, in the place of I am not going to write it as mr square because mr square is a moment of inertia only for a ring. Had it been a disk, it will be mr square by 2. But I will write I in terms of a common formula that is mk square. That is the reason why we actually define radius of gyration. So we'll write it as mk square. And since they have mentioned it rolls without slipping, omega is equal to v by r. Accepted? So m gets cancelled. GH will be equal to v square plus k square v square by r square. The whole multiplied by 2, the 2 will go to the other side. So if I take out v square common from this, 1 plus k square by r square. So v will be equal to root of 2gh divided by 1 plus k square divided by r square. So there is the formula actually. Now how to apply it for this problem? Hence v is equal to root of 2gh divided by 1 plus, what is the radius of gyration of a cylinder? About its center of mass.
R by root 2.
Yes, r by root 2. So k square will be r square by 2 and you have r square in the denominator. R square and r square will get cancelled. Root of 2gh divided by 3 by 2. So root of 4gh by 3. Is there an option like that? Actually, the square root is for everything. Root of 4gh by. Got it? Okay, wow. Shall I proceed?
Yes, sir.
So let's look at the fifth problem. So an inclined plane makes an angle of 30 degrees with the horizontal. A solid sphere rolling down its inclined plane from rest without slipping has linear acceleration equal to. So this linear acceleration also has a formula. I will derive and show. First, let me copy this question. Any idea what is the formula? Anybody? So if this is theta, any object is rolling down. Okay. So when you want acceleration, remember you have to apply the concepts of Newton's laws of motion. When you want velocity, you can apply the concepts of energy. Mg sin theta, normal, friction. Right? Angular velocity is omega. See, remember, one common mistake that happens is, since many people see the word without slipping, they think that friction is not there. Friction is a necessary force, because if the object has to rotate, that is the only force that is going to provide torque. Otherwise, if friction is not there, see what would have happened. What would have been the torque due to normal?
Zero.
Torque due to mg sin theta?
Sir,
That is
zero
also
again.
zero again, because both are passing through the axis of rotation. So friction is the only force that is going to provide the necessary rotational torque. Okay. So the torque produced is F into R is equal to, can I write it as I into alpha, where alpha is the angular velocity, angular acceleration, right? But alpha is nothing but A divided by R. Since alpha is equal to A divided by R, where A is the acceleration of center of mass. Similarly, mg sin theta minus F is equal to M into A, right? So mg sin theta minus, in the place of F, can I write it as I into A by R is equal to M into A. But how do we write I in terms of radius of gyration? Mg sin theta minus mk square into A divided by R is equal to Ma. M is gone. So g sin theta is equal to A into 1 plus k square divided by R square, which implies A is equal to g sin theta divided by 1 plus k square divided by R square. So this is the acceleration formula for an object rolling down an inclined plane without slipping. See, if suppose the object is not having the tendency to rotate, okay, I'm repeating it. If the object doesn't have the tendency to rotate, can I say the radius of gyration is 0? If I take k is equal to 0 and substitute it here, what is going to happen? What will be the acceleration?
G sin
G
theta.
sin theta.
G sin theta, we saw it somewhere else. Where was it?
Acceleration on an inclined plane.
That is only the translational acceleration, right? So when an object is kept on an inclined plane, when it is sliding, right? When it is sliding, its acceleration is g sin theta. Whereas when the same object is rotating, it will be g sin theta by 1 plus k square by r square. So this is like a special formula also. So according to this question, what is the value of theta? 30 divided by 1 plus k square is how much? It's a solid sphere. Yeah. So k is root of 2 by 5 into r. So k square will be 2 by 5 times r square. You have an r square in the denominator. This and this will get cancelled. So a will be equal to g sin theta divided by g sin 30, that is g by 2, divided by 7 by 5. So it will be 5g by 14. I hope it is clear. So till here, it is the derivation part. Okay. So I'm proceeding to the next question. That is the sixth one, right? A cord is wound around the circumference of a wheel of radius r. The axle of wheel is horizontal and the moment of inertia of it is I. A weight mg is attached at the end of the cord and falls from rest. After falling through a distance h, the angular velocity of the wheel will be. Let's see. See, there is a cord. Cord means you can think it as a wire. That's it. Okay. It is wound around what? The circumference of a wheel. When they say wheel, you can consider this wheel as a disc of radius r. The axle of the wheel is horizontal. The axle of the wheel is horizontal and the moment of inertia about it is I. Okay. A weight mg is attached to the end of the cord. So there is a weight mg that is attached. Now what will happen is this mg starts falling down when this mg has traveled a distance h. Then what would be the angular velocity of the wheel? Guys, tell me what is the concept. Yesterday uh, uh, I showed you a problem with a cord and my mobile. You remember? So when you pull, what will happen? The wire will keep coming out, and the wheel will also start rotating, right? So this is the axis through which this is the axis about which it is rotating. It is like this. It is a horizontal axis. Now tell me how to solve this problem. So what kind of kinetic energies are related to this object? Is it only rotational, only translational, or both? Guys, what is the answer? Is it how many kinetic energies does it possess?
Sir, after falling from rest, it possesses rotational and translational kinetic energy.
Which one? The wheel.
Yeah, the wheel.
But that's what I'm just reading. See, the axis of the wheel is horizontal and its moment of inertia is I. I don't think the wheel is moving. It is rotating about a fixed axis. See, here what is happening? You don't have a fixed axis. Or I can say the axis of rotation itself is moving. But here the question is slightly ambiguous. Cord is wound around the circumference of the wheel. If I take it as a fixed wheel, okay, let us assume this question is given as a fixed wheel. Now tell me what are all the kinetic energies it possesses?
Rotational.
It will have only rotational kinetic energy. But how can you say who is actually the reason for the rotational kinetic energy?
Mg.
Yes. So can I say mg into h, that is the decrease in potential energy, is equal to the increase in kinetic energy half I omega square. So mgh would have been half into I is I only, So then what would have happened? Then we will get the answer in one step. So omega square is equal to 2 mgh divided by I. So omega will be equal to root of 2 mgh divided by I. Are you guys able to understand? Had it been a fixed wheel, but if you see, none of our answers are matching actually, right? So if the wheel is having translational motion as well, then what would have happened? Then I can write mgh is equal to, did you understand, first of all, do you guys understand why I wrote mgh is equal to half I omega square?
Yes, sir.
Okay. See, suppose you have a confusion, like I don't know whether to apply energy conservation or something, you can always apply work energy theorem. I'll tell you, what does work energy theorem state? Work energy theorem is work done is equal to change in kinetic energy. Here, who is doing the work? Mg is doing the work, right? So mg multiplied with displacement is the work done is equal to change in kinetic energy. So final kinetic energy minus initial kinetic energy. They both are same, right? In a similar context, what will happen here? mgh will be equal to half I omega square plus half mv square. So mgh will be equal to half I am not disturbing, omega square. In the place of v, I'm going to write it in terms of r omega. Half into m into r square omega square. So 2 mgh is equal to omega square into I plus mr square. So omega will be equal to root of 2 mgh divided by, guys, I don't know which one is right because I'm not sure of how this wheel is. But are you guys able to understand? Had it been fixed, had it been moving, what would have happened?
Yes, sir.
Yeah. Make a note of both. Shall I move on to the next one? Yes. A solid sphere, disk, and solid cylinder, all of same mass and made up of same material, are allowed to roll down from rest on an inclined plane. Then who will reach the bottom first? See, any object will be able to reach the bottom first, provided it has dash velocity. An object will be able to reach a point soon, provided it has dash velocity. I'm talking about a comparative basis. Should it have greater velocity or less velocity?
Greater velocity.
It should have greater velocity. So what is the formula for velocity that we know for an object rolling down an inclined plane? 2gh divided by 1 plus k square divided by r square. Say they told they have the same mass and made up of the same material. So from this, can I conclude that velocity is inversely proportional to k square by r square? So if you calculate k square by r square, whichever is going to be least will have greater kinetic energy, which is going to be least among all the three. So for a solid sphere, disk, and solid cylinder. So for a solid sphere, what is the value of k square by r square? It is 2 by 5. For a disk, it is 1 by 2. For a solid cylinder, it is 1 by 2. Now, out of all these things, this is 0.4, 0.5 and 0.5. Out of all these things, this is less. So when this is less, velocity will be more. So which one will reach the bottom first?
Solid sphere.
Yes. Okay. Next. See, these kind of problems you can expect in integer type questions. Next. A solid sphere is rolling on a frictionless surface. Okay. As shown in figure with the translational velocity of v meter per second. If the sphere climbs to a height h, then the value of v should be. So what should be the value of velocity we need to give here so that it is able to reach this height? So they've asked the answers in terms of inequality. What is the last option? 10 by 7. No? It is 10 by 7 GH. How to proceed this? So how to proceed? See, wherever height comes from, by default, it is only energy conservation. They've told frictionless surface. So when I say frictionless surface, energy is conserved because there is no non-resistive force. So what if I take this point as A and this point as B? What is the total energy at point A? If I take the ground as the reference line, you guys tell me, what are all the energies possessed by the object at point A?
Half mv square.
Is that all? I
Plus
underlined the word.
half I omega square.
Then it has rotational also, no? Half mv square plus half I omega square. Okay. Next. What is the total energy at B?
mg.
Is it only mgh? Plus the object is still rolling, no? Half I omega square. Can I put it like this? Does it make sense? Are you able to understand? So initially it had only rotational kinetic energy that got converted to what? Mgh plus half I omega square. Why didn't I put translational velocity here? Because when they told if sphere climbs up to height h, what can I say about its translational value? It would have come to instantaneous rest. The translation motion would have come to instantaneous rest, but the object would have got still rotating. So the logic here is the total energy initially which it possessed should be greater than or equal to the total energy which it possesses at point B. Right? So half mv square plus half I omega square should be greater than or equal to mgh plus half I omega square. So this and this will get cancelled. So mv square should be greater than or equal to 2 mgh. M and m will go cancel. So velocity should be greater than or equal to root of 2gh. That is a mean. Okay. Nine. Moment of inertia of a disk about its own axis is I. Its moment of inertia about a tangential axis in its plane is.
Sir, is it 3I?
How did you get that?
So I did ml square by 2 plus ml square.
mr square, okay. mr square by 2 plus mr square. Then it should be 3 by 2 mr square. No?
So is it 3 by 2 mr square?
But here it is 3 by 2. I is given. So mr square by 2, if you take it as I.
So then 3I will come.
But you people did a mistake. I understand what mistake you're doing. I'll tell you. Seriously. I have to show this, okay?
Sir, it's 3i.
No, it is not 3. I'll tell you what. I'll ask you certain questions. Tell me, did you people do it like this? Wait, I'm switching on my video. See, this is the disk. Okay. You took mr square by 2 plus mr square. Am I right? So you applied parallel axis theorem. Is that right?
Yes, sir.
Sir.
So moment of inertia of, listen to this carefully. Moment of inertia of a disk about an axis passing perpendicular to it is mr square by 2. And you calculated the moment of inertia about a tangential axis, which is, there is one important point they mentioned in the question at the end. What is it? What is the moment of inertia of this disk about a tangential axis? What is the last part of the statement? In the plane, right? You people calculated perpendicular to the plane. This is the plane of the disk. So what you should have actually done is, you should have actually calculated what is the moment of inertia of this disk about one of the diameters, because they asked what is the moment of inertia about this axis. It is not this axis, it is this axis. Means the disk is rotating like this. Are you able to visualize it?
Yes, sir.
So
Okay. You people calculated when it is rotating like this. That is not the way it is rotating. You keep it like this, this is the way it is rotating. That is the meaning of tangent and in the plane. So in this question, you need to apply both the theorems, because we know the moment of inertia about this axis. If I take this as z-axis, parallel axis theorem is applicable for a two-dimensional surface. This is two-dimensional. So Iz is equal to Ix plus Iy. What is the value of Iz? You people simultaneously write. No, I can't write it now. So Iz is
ml
what is
square
the
by
square
2.
by 2.
mr square by 2. That is I. Right? That is the point according to the question. So wherever you see mr square by 2, you can replace it with I. That we will do it at the end. As of now, this is mr square. This is Ix and let me, okay, this is Ix and let me say this is Iy. Both these Ix and Iy are nothing but perpendicular diameters, right? So can I say moment of inertia about x-axis is the same as moment of inertia about y-axis because this is a symmetric object. Accepted?
Yes.
So what is the relation between Ix, Iy and Iz? What does perpendicular axis theorem state? The moment of inertia about any axis which is perpendicular to the plane is equal to sum of the moments of inertia about two axes which are perpendicular and lying in the plane. Correct? So Ix and Iy are in the plane, Iz is perpendicular to the plane. So can I say Ix plus Iy is equal to Iz? Write it down. Ix plus Iy is equal to Iz. What is the relation between Ix and Iy? They both are
Equal.
Equal.
They both are same because both are diameters only. It's a symmetric object. Whether you take it like this or you take it like this, it's not going to make any difference. So you can write 2 times Ix is equal to mr square. So what is the moment of inertia about this axis? What is the moment of inertia about x-axis or y-axis, whatever it is? It is mr square
By 2.
2 times Ix is mr square. Up Ix evolve. 2 will go to the other side, no? It is mr square by see Ix, Iy.
R square by 4.
Ix is mr square by 4. It is mr square by 4 or I by 2. Correct? Because half times mr square. We know that mr square is I. Please make a note of it. Mr square by 2 is I. Am I clear till this point?
Yes, sir.
Sir, how do you
Yeah.
calculate Ix, sir?
See, Ix, no? Iy. Ix plus Iy is equal to Iz. Are you clear till
Yes,
this
sir.
point? Okay.
Yeah.
I told you Ix and Iy are same. Clear?
Okay, sir. Okay, so should we find
Got
Ix? Okay. Yeah.
Ix or Iy, it's up to you. It's up to you. Ix and Iy doesn't make any difference because of its symmetric property. I'll tell you what are the difference, okay? If suppose you have calculated Ix, then you calculate about the tangent like this. See, suppose you have calculated about Ix, then you will take the tangent like this. If suppose you have calculated about Iy, then you will take the tangent like this. Both are same.
Yes, sir.
Okay. So suppose you have calculated Ix, which is mr square by 4. Now the question is very important. They are asking about the tangent, which is in the plane, means it is like this. Now, what can you say the moment of inertia of this tangent as? Moment of inertia about this tangent is equal to moment of inertia about x-axis plus mr square. Correct? So moment of inertia about x-axis is mr square by 4 plus m into this distance square, that is mr square. So how much is the answer coming?
5 mr
AMR
square
square by 4.
5 mr square by 4. That is half into 5 m. I can say 5 by 2 into mr square by 2. Both are same. 5 by 4 mr square is same as 5 by 2 into mr square by 4 also. Sorry, mr square by 2. But mr square by 2 is how much?
I.
I. So what is the answer?
5 by 2 I.
5 by 2 y.
Is there an option? I think you have that option, right? 5 by 2i. Right? So that's the answer. So this problem, what is it? So you need to apply both the theorems, but what is the priority? Will you apply parallel axis and then go for perpendicular, or the vice versa? You will apply
Perpendicular first.
perpendicular axis first, and then you should go to the parallel. Right? I hope you all were able to visualize it. Right?
Yes, sir.
Yeah, good. So in this chapter, the challenging part is considering the axis of rotation. If you're able to master that, this chapter is easy. That is why many people are scared of this. So it is 5 by 2i. Is there anyone who's not clear? Okay. Again, these kind of problems are also regular. Like what they will do is they will combine the objects and ask the moment of inertia. Remember, moment of inertia is a scalar quantity, so you need not take any directions into consideration. You can add them. Now see, there are three rings, each of mass m and radius r are arranged as shown in the figure. The moment of inertia of the system about the axis y into y dash will be how much? This is m, and this is m, and radius is r. Correct? So how to find the moment of inertia, guys? One thing I can say, the total moment of inertia is equal to I1 plus I2 plus I3, where I1 is the moment of inertia of the first, I2 and I3 are the moment of inertia of the second and 3 respectively. Now let's break it down into three parts: first, second, and third. So y dash is the axis about which the total moment of inertia is needed. So y dash with respect to the first one is acting like what?
Diameter.
Diameter. So what is the moment of inertia of a ring about its diameter? Just like how we did for a disk.
mr square.
Ix plus Iy is equal to Iz. Iz is what is mr square. Correct? So 2 times Ix is equal to mr square. So Ix is how much? Mr square by 2. Is there anyone having a doubt on this? See, this is the same as how I explained for a disk. Only difference is for the disk Iz was mr square by 2. Here it is a ring, it is mr square. Same logic. Right? So what is the moment of inertia of the first one? mr square by 2 plus with respect to the second and third, how is y dash acting?
Tangents.
Tangent. See, when you say tangent, you need to be careful. Is it a tangent in the plane or is it a tangent in the plane perpendicular to it?
Tangent in the plane.
In the plane, right? So tangent in the plane means what are we supposed to do? Same logic. First perpendicular axis, then parallel axis.
Parallel.
So you know what is the moment of inertia about the diameter? That is mr square by 2. So if you apply parallel axis theorem, how much will be the moment of inertia about y dash? It will be mr square by 2 plus mr square. Accepted? That is the moment of inertia about an axis through the center of mass, which is mr square by 2 plus m into distance of the square between both the points. The same is the case with I3 also. So what will be the answer?
7 mr square by 2.
7 mr square by 2. You have an option? Yes. That's the answer. Got it? How to calculate?
Yes, sir.
Good. Okay, I'm moving on to the next question. One circular ring and one circular disk, both are having the same mass and radius. The ratio of their moments of inertia about an axis passing through their centers and perpendicular to the plane is a very simple question. This is a direct formula. Moment of inertia of the ring to the moment of inertia of a disk about an axis passing through the center. They are asking about Iz. mr square divided by.
mr square by 2.
That's it. Answer is 2:1. Where is it? Yeah. Option B. It's a very simple question. Right. Next. Let's see. I think they have cut the portion. Okay, let's see. I think this should be a good problem. So from a disk of radius r, a concentric circular portion of radius smaller is cut. so as to leave an annular disk of mass capital M. The moment of inertia of this annular disk about the axis perpendicular to its plane and passing through its center of gravity. So from a disk of mass, from a disk of radius r, from a disk of radius r, the concentric circular portion of radius r is cut. So the circular portion that is removed is let's say there is the circular portion that is removed. Okay. So this is capital R, this is small r. The moment of inertia of the annular disk about an axis passing through its plane and passing through the center of gravity is. But here, how much mass is getting removed is what we need to know. They have given it. So the annular disk's total mass is capital M, means how much is the removed portion. As I look into this and I'll get back. Okay. So this problem I'll do it later. Give me some time. Next. So the moment of inertia of a straight thin rod of mass capital M and length L about an axis perpendicular to its length and passing through one of its ends. You can directly say ml square by 3. 14th one. 4 thin rods of mass M and same length L form a square as shown in the figure. Moment of inertia of the system about an axis passing through its center and perpendicular to its plane. Can you guys tell me? How to do? So what is the, see, if I take only one rod, okay, are you guys there? If I take only one rod, what is the moment of inertia of this one rod about 0.0? Are you all there?
Yes, sir.
Yeah, tell me. So what
ml
is the
square by
moment of
3.
inertia of this rod about point? No, it is not. Oh, sorry. Yeah, yeah. So how will it be? How did you get that ml square by 3? Because you would have
Parallel
calculated
axis theorem.
parallel axis theorem. Ix plus m into, what is this distance, guys? It is L by 2. So
L by 2.
it is ml square by 4. So what is the value of Ix? Ix is ml square by 12 plus ml square by 4. That will be ml square by 3. So like that, how many such ml square by 3s you have?
4.
So what will be the answer?
4 by 3
4
ml.
ml square.
4 by 3 ml square. Okay. Next. 15. The moment of inertia of a uniform circular ring having a mass m and radius at r about an axis tangential to the ring and perpendicular to its plane. It's just one step. So what is the moment of inertia of a ring about its center of mass and perpendicular to its plane?
mr square.
Mr square. So what theorem are we supposed to apply here?
Parallel axis theorem.
So what is the answer?
2 mr square.
That's right. Next. The moment of inertia of a uniform rectangular plate about an axis passing through its midpoint and parallel to its length L is. By default, see, if at all you want to guess certain things, no, you can eliminate B and C. Why?
D
B and
cube.
C cube. So they're dimensionally wrong in the first place, right? So it should either be MB square by 4 or MB square by 12. What is the answer? You can make a note of it. Generally, the moment of inertia of a rectangular plate about an axis passing through the center and perpendicular to the plane is m into L square plus B square the whole divided by 12. So here what are they saying? If you take this as length L and breadth B, the moment of inertia of a uniform rectangular plate about an axis passing through its midpoint and parallel to its length. So if you take it like this, right, then what will be the answer? It is MB square by 12. So why you actually got ml square plus b square by 12 is, if I take this as x, it is mb square by 12. If I take it as y, then what will be the moment of inertia about y? It is ml square by 12. Right? So if I take the z-axis which is perpendicular to both, then iz will be equal to ix plus iy, where x and y both are in the plane of the rectangle. That is why it is m into L square plus b square by 12. So this is iz, this is iy, and this is ix. So according to the question, they asked ix, which is mb square by 12. Okay, next. The moment of inertia of a circular ring about an axis passing through its center and normal to its plane is 200 gram into 200 gram centimeter square. The moment of inertia about its diameter. Can directly tell me? We have already done this problem. So moment of inertia about the diameter, is it less or more? So 2 times Ix is equal to Iz. Iz is mr square. So Ix will be equal to mr square by 2. So they have already given mr square. Mr square is 200. So answer will be 100. Right? If anybody is not clear, let me know. Okay. So let's try out this problem.
Sir,
Yeah, tell me.
If they didn't mention anything about the plane and simply ask about its diameter, then it's
Diameter
perpendicular.
will be in the plane only. Diameter is in the plane only. Diameter cannot be out of the plane. No? So if you take a circular disc should have its diameter only in the plane. Only about tangent they will see in the plane or perpendicular. Okay?
Yes, sir.
Are you clear? Yeah.
Yeah.
From a circular disc of radius r and mass 9m, a small disc of radius r by 3 is removed from the disc. The moment of inertia of the remaining disc about an axis perpendicular to the plane of the disc and passing through O. What is O? O is, let's say O is center. They didn't give any diagram, right? Have they? They told the disc is removed, but from where? Okay, the diagram is given. Let's try. So how do we proceed? Any idea? Since this portion is hollow, we need to see what is going to be the total moment of inertia. So how to proceed, guys? So they are asking the moment of inertia of the remaining disk, correct? So can I put it like this? Tell me whether it is right or wrong. Moment of inertia, the total value is equal to the moment of inertia of the removed disk plus the moment of inertia of the remaining disk. Can I say it like this? Right here, it will not get subtracted and all. It will get added only. So that because we are talking about the total value. So what is the moment of inertia of the removed disk? About which point? About O. How do I calculate it? Tell me, guys. So moment of inertia of the removed disk about O, if I take this point, the center as P, what is the moment of inertia of the disk about P? That is
mr square.
mr square
by 2.
It is mr
mr
square by 2.
square by 18.
So mr square, or I will say m small r square divided by 2. Okay. But I have certain questions. What is the mass of the removed portion? We don't know the mass of the remote portion. Let's say, just a minute. So what is the mass of the remote portion, guys? How do we calculate it? Not. Yeah. Yeah. Tell me, guys. So what is the mass of the remote disk? How do we calculate it? So since they mentioned it as a disk, what is the type of density we can define?
Surface density.
Yes. So can I say sigma is equal to 9m divided by pi r square? The sigma of the smaller disk will be m divided by pi into how much is the radius of the removed disk?
R by
R by 3.
R by 3. So it will be pi into r square by 9. So 9 capital M divided by pi r square is equal to small m divided by pi into r square divided by 9. Pi r square will get cancelled. M and M are gone. Sorry. 9 will go up. So 9 is equal to 9 times small m. So M will be equal to capital M. Right? So the mass of the disk that is removed is capital M, where 9m is the total mass of the disk. Correct? So it is capital M into R is R square divided by 9 divided by 2. So as you told, it is mr square by 18. Now the question is, what is the moment of inertia of the removed disk about O? It is the moment of inertia about point P plus mass of the disk that is removed into what is the distance square, guys? So M into
2R
distance
by
square.
2.
So 4r square by 9. If I write this as 8 by 18, okay, I'll write it as 4r square by 9 itself. So if you take LCM, you become 8. 8 plus 1, 9 mr square divided by 18. It should be mr square divided by 2. Right? If you take LCM and solve, it should be mr square by 2. Right? That is the moment of inertia of the removed disk. What is the moment of inertia of the remaining disk? Moment of inertia of remaining disk is how much?
9 mr square by 2.
9 mr square by no. What are they asking actually? The moment of inertia of the remaining disk. See, moment of inertia of the remaining disk is not mr square by 2. That's what we need to calculate. What is the total moment of inertia? Total moment of inertia is 9 mr square by 2, correct? So 9 mr square by 2 is equal to moment of inertia of remaining disk plus moment of inertia of the removed disk, that is mr square by 2. So what will be the moment of inertia of remaining disk? That will be
4
7
mr.
m. 7 letter.
No, sir. 8 mr square by 2.
Where is it 8 mr square by 2? Oh, sorry, yeah, 8 mr square by 2. That is 4 mr square, correct. So is there an option for mr square? Yes, it is 4 mr square. I hope it is clear for everyone.
Yes, sir. Yes, sir.
Yeah. So we'll do 2 more problems and we'll wind up. I think the 2 problems are easy. The moment of inertia of a thin rod of mass m and length L about an axis perpendicular to the rod at a distance L by 4 from one of the ends. ml square by 12 plus ml square by 16. So LCM will be 48. So 7 ml square by 48 is the answer. I applied parallel axis theorem. Question number 20. A wheel has a speed of 1200 revolutions per minute and is made to slow down at a rate of 4 radians per second square. The number of revolutions it makes before coming to rest. Do it fast. So wheel has a revolution of 1200. Wheel has a speed of 1200 revolutions per minute. Have they given you angular velocity or frequency?
Frequency.
Frequency converted to angular frequency by multiplying with 2 pi. and it is slowed down at a rate of 4 radians per second square. That is what?
Angular acceleration.
Angular acceleration. Number of revolutions it makes before coming to rest. Find the value of theta. Theta is equal to, or we can say omega square minus omega naught square 2 alpha theta, right? Omega square is 0 minus omega naught square is 2 pi into 1200 revolutions per minute is how many revolutions per second?
45.
No, it is 1.
20.
I'm asking revolutions per second. 120, 1200 divided by 60. No, it is 20. So 20 is equal to 2 into alpha is minus 4 because they told it is slow down at a rate. So minus 4 into theta. So theta will be equal to how much? So it will go 10 times. Theta will be 5 pi. Oh, I'm sorry, square, right? That's what I'm saying. It's only 2.5 revolutions. So minus 2 pi into 20, the whole square, is equal to 2 into alpha is minus 4 into theta. So minus is gone. 4 pi square into 400 is equal to 8 theta. So it goes 2 times 200. So theta is equal to 200 pi square. So number of revolutions will be how much? Theta divided by 2 pi. That will be 100 pi. 100 pi is 3.14 into 100. Answer is 314. Did you understand how I did number of revolutions as theta by 2 pi? Because one revolution would have covered 2 pi radians. 200 pi square radian would have covered how many revolutions? It is 200 pi square divided by 2 pi. That will give you 100 pi. Pi is 3.14. 3.14 into 100 is 340. Clear? So these are all the problems that are based on moment of inertia and the objects rolling down an inclined plane. So this problem alone, you can try it as homework. Okay. If there is any doubt, you can approach me. Let me check the other one. You can try 21, 22, 23 also. Those are all easy only. You can try them. If you have doubt, you can approach me. Yes. Next class, what we will do is we will do some previous year problems so that we get an idea of what kind of questions are asked. Because this chapter will cover the whole mechanics. If you see, we applied kinematics, we applied work energy theorem, we applied rotation mechanics, everything will get covered. So it's a good chapter to practice. Okay. So that's it from my side for today. Just wait for a minute.